Okay, well, let's take a look at, let's do B here first. And the reason that I'm doing B is because it looks more complicated because it's not y equals, but this one here won't have whole numbers. It'll have some fractions in it. So they're both a little bit more complex, but for different reasons. So this one right here, this is different because it's not y equals. They're both x plus something or whatever. So we have to get y by itself. So that's why this one's maybe a little bit more complex. However, this one right here is a little more complex because in the end you have fractions. Which, I mean, you could add or subtract fractions, you just need a common denominator. But it's just a little bit more complex than the first one. So let's take a look here. We need this to be y equals. X plus 3y equals 15. And okay, so I guess what I'll need to do, I'm just make sure I have enough room here. X plus 3y equals 15. And 3x minus 5y equals 17. So I'm going to be crunched for space in this question because I need to get y alone. So I got to do that. So I'll do this one first. I'll minus the x over to the other side. So 3y minus the x, and there's a positive 15. Doesn't have a plus sign, but it is just a constant number that's positive, so I had to put the plus sign there. And then I can divide by 3, divide by 3, divide by 3. Y equals negative x over 3 plus 15 over 3. Now that would just be 5. So I'm going to put a 1x over 3. Just there is no 1 there, but just so we have a number. For this other equation here, I'll move over the 3x, so I'll subtract it. Just like the first question on the left there, I can't combine the x with the 17 because it is not, they are not like terms. So minus 5y equals the negative 3x plus 17. And like the last chapter, I like to write the x first. And then I can divide by negative 5, negative 5, negative 5. So y equals 3 over 5 x plus 17 over 5. Now that can't be reduced, so just say 17 over 5. And there's a negative sign, so it has to be negative, so I'm just going to make this a subtraction. Okay, so now I have these two equations. They both have fractions in them, but they're not too bad because now we can actually get to doing this question, and you always start with saying, well, in order to get rid of the letters, you need to go y equals y, and then I just put one of the y's over there. So negative a third x plus 5 is one of the y equals right there, equals the other one, which is 3x over 5 minus 17 over 5. And then we just do what we did last time, so let's get a common denominator, which is 15. So times that by 3, times that by 3, times that by 3, times that by 3, I guess times that by 15, and by 5, and by 5. So I have a negative 5, there's an x over 15, plus 15 times 5, which is going to be 75 over 15, equals 9 over 15 x, and then 17 times 3, so 51 over 15. And now that you have all the denominators of 15, you can multiply the numerator by 15, which will cancel out the denominators, and multiply this numerator by 15, which will cancel out with all the denominators. Okay, so now you've got a negative 5x left over with the 75 and the 9x minus 51. And I can move over the smaller x or the more negative one. Well, negative 5 is the more negative one, so I'll add it over to this side. So 75 equals 14x and then minus the 51, which then I can add. Well, I'll have to change that here, so I'll add the 51. And those can cancel. Now 75 and 51 will be 126, which is then equal to 14x, and then we can divide by 14. Okay, well, I don't remember here, so let's do this off. How much room do I have? I have a little bit. Okay, so 14 into 126. Oh, great, that doesn't really help, does it? Because 14 can't even go into 1 or 2, it has to go into everything. Okay, so, I don't know, 14, 9 maybe? 9 times 4 is 6, 3, 9, 10, 11, 12. Okay, so it is 9. There we go. So this is 9. Which equals x. So x is equal to 9. Nice. Now we need to find y. So I just want to do this the same. So to find y, we're going to choose an equation. And I'm going to choose the easier one. Well, they're both somewhat the same. So x plus, I'll use the top one, x plus 3y equals 15. So x plus 3y is equal to 15. And I know my x here is 9. Plus 3y is equal to 15. So I need to find out what my y is. So I'll just subtract the 9 from both sides. So 3y is equal to 6. Nice. Divide by 3, which will get me 2. Y equals 2. Hold on here. There we go. Y equals 2. Therefore, our x and y coordinates. So our x is 9 and our y is 2. So x is 9. I'll put it over here actually. Therefore, just because I'm out of room, x is 9 and y is 2. So there we have it. That point works. Okay. So I'll just kind of zoom this out a little bit, but maybe the PDF that you see will be a little bit nicer. Okay, so let's take a look here. What was complicated about this one, or at least a little more? Okay, so it did have y equals, but doesn't look like there's any fractions, so I don't know what I was writing, but let's just see. So I start with y equals y, and so one of the y's is 5x minus 13, so I'll put that on one side, and 3x minus 6, put that on the other. And now I'm going to move the smaller x. So I'll move the smaller x, so I'll move the 3x over to here. So 5 minus 3 is 2x, and there's a minus 13 is equal to negative 6. So we can now add the 13 over. $2x is equal to 13, 6, 7. Oh, here's why. Divide by 2, and you get 7 over 2. So that's our x. 7 over 2 is 3.5. Okay, so our x is 3.5. Now we need to find y. So to find y, we need to choose an equation. Okay. Choose the easier one, so maybe that one, just because it's smaller numbers, I don't know. 3x minus 6. So y equals 3x minus 6. So y equals 3 times x, which I'm going to put at 7 over 2 minus 6. Now remember, this is over 1. So when you multiply fractions, you do the tops together and you do the bottoms together. So 3 times 7 is 21 over 2 minus 6. And now to add fractions, you need a common denominator. So again, that's over 1. So we'll times this by 2, and we'll times this by 2. So y is equal to 21 over 2 minus 12 over 2. And now they have the same denominator, so we can combine them together. 21 minus 2 is 9. So y equals 9 over 2. Or that is 4.5. So then we have therefore, what is our point? Our x comma y. So our x was 3.5. What was that? 7 over 2. And our y was 9 over 2. So was that any more complicated? Not really. But you just, because I don't know, there was way more work that went into this one where we had to create two equations and then set them equal to each other. And when we did set them equal to each other, we had to get a common denominator, which was 15, and then multiply the numerators by 15 to cancel out with all of these denominators here. So we had to do that, and then we could do all the work to get 9, and that was a nice number. Believe it or not, this looks super complicated with all these fractions in it, and then just spat out a number of 9. This one didn't have much complications at the beginning there because it was already y equals, and so some pretty simple algebra got us 7 over 2. And then we had to plug that into one of the equations, and I guess remembering your fraction rules could be a part that that you trip up on, but that the numerators multiply when you are multiplying and the denominators multiply. You do not need a common denominator when you're multiplying fractions, but later on down here when you're adding fractions, you do need a common denominator. So keeping all of that in mind. Okay, we got 2 more questions to do. So I'll zoom out a little bit, but there's no way I can get all of this in one shot here. So the PDF would probably be an easier thing to use.